See if y'all can come back to me now. How many of you actually come back? Can you make it? Can you make it back? And can you hear me? Phew. Now there's the challenge. Can you make it back? Yay! So did you get that answer? What is it? You're right, I went after my Diet Dr. Pepper because I couldn't take it any longer. I needed a Dr. Pepper. Yay! Y'all made it back. That was goal one, is to see, could you make it back into a stream? Let's see how many of you can make it back. Sorry about that, guys. I want 2 different ones for purposes. Yeah. For future references. So people can watch one lecture and then watch another. And you too, if y'all want to go back and just watch the multiple operations later, you can watch that later. We'll see how many of y'all can do it back in. Thomas, did you come up with this answer? Did you get it? What'd you get? What'd you get? What was it? What was it? I'm going to work it while people come in. I may have run off all my viewers. What was I thinking? I wanted to stop it. Start it again. Hey, there's somebody else. A couple more people coming in. Yay, way to find me, way to find me. What was the answer? What was the answer? Was your early bird? Oh, okay, good. Oh, okay, I don't blame you. Needed some coffee. I needed Diet Dr. Pepper. True statement. I'm with you on that. What'd y'all get? What'd you get the rest of? What'd the rest of y'all get? All right, we've got a 23. Anybody get anything different? 23. I know that I'm going to use please excuse my dear Aunt Sally. Or I'm doing the grouping symbols. Jimson would say, what would Jimson say? Jimson doesn't say, please excuse my dear Aunt Sally. Jimson says, Gimma. Gimma? I think it's Gimma. Grouping symbols, exponents. There's no such thing as division, it's just multiplying by a fraction. So multiplication. In our case, we say multiplication and division left to right, and then addition and subtraction left to right. But Jimson would, subtraction. Jimson would argue that there's no such thing as subtraction, that you're just adding a negative. That's all you're doing, it's just addition. So it's really just Gimma. Grouping symbols, exponents, multiplication, and addition. Okay, so let's go through this and do it real quick. You got 23, we got 2 with 23. So let's see if it seems to be a common answer. Let's see if that's what we get. So I'm going to do inside my parentheses first. So 5 minus 2 gives me 3. And then I say, okay, then after my grouping symbols, then I look at my exponents. Well, 3 squared is 9. Then I have to do my multiplication and division from left to right. So multiplication is 18. I didn't have a division. And then add and subtract from left to right. So I've got 27 minus 4. Hey, I got 23 too. Yay! Now that was a good warm-up, and the reason I have that on there is when we have multiple operations like this, we have a certain order that we have to do them in. We have this order of operations that we go through. Well, with our transformations, when we're doing multiple operations, so now instead of just doing one operation, we're going to do multiple operations, then all of a sudden I need an order of operations for those two. I need to know when, what order to go in. And it turns out that the order is kind of similar. Or at least I can use this to help me remember the order of operations when I'm doing my transformations. So for instance, my parentheses are first in my order of operations. So first thing I'm going to do with my transformations order of operations is I'm going to do those horizontal shifts. Because if you think about it, inside the parentheses, when I'm adding and subtracting inside the parentheses there, it's causing a horizontal shift. So I'm going to do those horizontal shifts first. That always needs to be taken care of first. The exponents, luckily, I don't have to worry about. Because the exponents in my functions tell me, if I've got an x squared, that x squared tells me the shape of it. So I don't have to worry about the exponents. The exponents just tell me what its parent is. So exponents aren't part of my order of operations. So just, that goes off. Then multiplication and division, well, when I'm multiplying a function by something, then I'm stretching it or shrinking it. I'm doing that dilation. So my vertical dilation or my horizontal dilation comes next. That multiplication where I'm dilating, my dilations come next. Also, when I multiply by a negative, really I'm just multiplying by a -1, right? So that's just multiplication 2. And this multiplication by a -1 causes a reflection. And if it's inside with the x, then it causes a horizontal reflection. But multiplying by -1 is just a reflection. So my multiplication causes a dilation or a reflection. And just like when I multiply, if I do 3 times 4 times 5, I can do it in this order, or I can do it in this order, because multiplication is commutative. It turns out that I can do the reflection first and then the dilation. These two, the order of those don't matter, they just need to be in the middle. So we do our horizontal shift first. We do our dilations and our reflections. And then last but not least, we're going to add or subtract outside the function. So when I take and I add or subtract outside the function, remember what that does is it affects my y values when it's outside. It's not inside with x. It's outside of the function. It's affecting my y value. By the way, that one's not in a grouping symbol. He's affecting my y value. That one's not affecting my x's. That's my y value. Who is my 2 Hispanic? Who is that? So that later I can give you bonus points. I'm glad you're back, though, and you're right. I was drinking my Diet Dutch Pepper. I'm going to want to be able to give you bonus later. So put your name in there somewhere, or on Discord tell me or something. Somehow or another let me know who you are so that I can give you bonus points later. All right, anyway, so this is a vertical shift or a vertical translation. Really, these are translations. Oops, that's not a verb. Okay, so this is the order that we're going to do it in. We're going to do our horizontal shifts first, and then we're going to dilate it, reflect it, and then last but not least, we're going to vertically shift it up or down. So that's the order of this operations for doing multiple transformations. So let's get started. Let's graph a few with multiple operations. how about, I'm just going to make some up as I go along. How about we do something, what's your favorite shape? How about like a, I've been doing a lot of cubic functions today. We could do, how about a cubed root function? I haven't looked at the cubed root function today. Let's do a cubed root function. So that we have multiple things going on here. So first of all, you look here and you go, this is my shape. I know this is a cubed root function. So, you know, I've got my cubed root function, my sideways here. Yeah, that's my cubed root function. Sideways 3rd Street. And Ms. Jimson's right. What are they? What are they? What are those points? Quick, what are my points? I'm going to write them down. You know the parent function here. What is it? Yeah, I'm walking like an Egyptian. That's what I'm doing. It's 3rd Street sideways. But as I walk down 3rd Street sideways, I'm walking like an Egyptian. I like that. -8, -2. That's the first one. Then what's next? -1, -1. Look, y'all got this. Yes. 0, 0, 1, 1, and I'm going to beat y'all to it. 8, 2. Oh, you're close. 8, 2, 8, 2. Because it's getting smaller. Okay, so now what is this +1 going to do to my graph? So that's the first thing, is I look at the shape. Then I'm going to go through and I'm going to say, hey, each thing, what's happening to each part of this? Good job, guys. Y'all got those points. That's what I want. Y'all spin them out that fast. Good job. Okay, so let's look at this positive 1 right here. What is that 1 going to do to my graph? Notice that it's inside with my x. Since it's inside the function with the x, I know it's going to affect my x value. And we know. So first of all, your x value, so you're thinking this direction. So horizontally, it's going to do something horizontally. And you know your x's. You know that they lie to you. So we're thinking that it needs to go this way, but no, those x values always lie. Always. So instead, it's going to go to the left 1. This is going to shift it to the left 1. Shift it left 1. So that's a horizontal shift. A horizontal shift, left 1. Or you can think, I'm going to subtract 1 from all my x values. I'm going to take away 1 from all my x values. Then, what about this -4? Notice it's not inside with the x. It's on the outside. So it's going to affect my y values. And my y values are on that vertical axis. So I'm thinking vertically. So what's going to happen to my graph vertically? Oh, well, y's are truth tellers. They do tell the truth. So they move down 4. Or from all your y values, you can just subtract 4 from all those y values. Or you can think this is a vertical shift or vertical translation. All right, so now I've looked at each one. I've told you what it is. I'm going to come over here and look at my order of operations and see what I need to do next. So a horizontal shift is first. So the first thing I'm going to do is subtract 1 from all my x values, or you can think of it as adding a -1. That's the same thing, right? From all my x values. So from all my x values, I'm going to shift them over to the left 1. I'm going to add a -1 to all my x values. So -1 plus -8 gives me a -9. -1 plus -1 gives me a -2. Negative 1 plus 0 is a negative 1. Negative 1 plus 1 is 0. And negative 1 plus 8 is 7. All right, then I have, the only other thing I have is the vertical shift. So I'm going to do that next. And to that one, I'm going to take, to make it vertically shift, I'm going to subtract 4 from all of my y values. So from all of my y values, I'm just going to subtract them down 4. So negative 2 minus 4 gives me a negative 6. Negative 1 minus 4 gives me a negative 5. 0 minus 4 is a negative 4. 1 minus 4, negative 3. And 2 minus 4 is a negative 2. So now let me just graph it. And what we're expecting to happen is it should move to the left and move down 4. Should move to the left and move down 4. So over 9, not negative 9, negative 6 should be a point. This is a point at, I don't know where to write it, negative 9, negative 6. So let's see if I can get there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Boom. Negative 2, negative 5. So I'm going to go negative 2, negative 1, 2, 3, 4, 5. Negative 1, negative 4. Negative 1, negative 4. Negative 1, negative 4. 0, negative 3. And 7, negative 2. 2, 3, 4, 5, 6, 7, negative 2. Notice it still has my walk like an Egyptian shape. There's that walk like an Egyptian shape. And then it moved to the left one. So, you know, it started here, moved to the left one, and then went down 4. 1, 2, 3, 4. Oh, sure enough it did. It just took that parent and shifted it over 1 and down 4. And we can algebraically just do it by adding that opposite and subtracting down off the y's. Yeah. So be sure and label your points. So negative 9, negative 6, negative 2, negative 5, negative 1, negative 4, 0, negative 3, and 7, negative 2. What do you think? Not too bad? Let's do a little harder one. Let's add a few more operations in there. Y'all still with me? Ugh. Let's try something with a little bit more to it. How about we do f of x equals, let's make it really tough. Let's say 3 absolute value x minus 2 plus 1. Okay, so the first thing we're going to look at is the shape. What is my shape going to be of this function? What's the shape there? First thing. What is that shape? Anybody with me? Y'all got this. What's the shape? What's the shape? So my shape is a, yay, it's a V. My shape's a V. And now I'm just going to look at each piece and I'm going to tell you about each piece. So like for instance, this 3. Notice that 3 is on the outside. It's not inside with x, it's on the outside. So because it's on the outside, we know that it's affecting the y values. And again, when I think about my y values, I think about this axis, so that means it's doing a vertical shift of some sort. And on the outside, it's being multiplied by that 3, so it's dilating it. It's stretching it. So we're going to have a stretch. Good, Austin, that's what I want. Yell at it. So it's a vertical stretch or vertical dilation. Is that how you spell that? I hope so, because I keep spelling it that way. Good, that's what you're supposed to do. Yell at it, like I do with Dora Explorer. It's behind you, it's behind you. Or in the middle of, what's the movie with the dinosaurs? Because I really did stand up in the middle of that movie and yell, shut the door, because their van was open, the door van was open, they needed to shut it. So now this -2, and if I'm going to do it algebraically, because it's affecting my y values, I'm just going to take each one of my y values and multiply them by 3. Then inside here, it's affecting the x values. So I'm going to take each one of my x's. So I'm thinking on my x values, x-axis, and my x-axis goes this way. So it's going to affect it horizontally, and it's just going to shift it over horizontally. Which direction? Think about those x's. Makes me think I want to go to the left, but instead I'm going to go to the right because those x's are liars. So I'm going to vertically shift it, horizontally shift it to the right. Or you can think of it as adding 2 to all your x values. Yay, that's exactly right. And then that 1 on the end, what's that 1 on the end going to do? Notice it's not inside with the x. It's on the outside. So it's not affecting my x. Instead, it's affecting my y's, which again is that vertical. And it's going to shift it up 1. Or it's a vertical translation up 1. It's affecting my y values. Oops, not 2, 1. 1. Okay, so I'm going to take all of that. Great. Now I'm going to take all of that, and I'm just going to do all of these in the right order. So I just have to think about now the order that I'm doing them in. So I look inside that parentheses first. Well, first I need my parent. So you tell me what are the points on that parent, because the points come first here. So the points on the parent are -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Hopefully you had that written down. You'd already done that. Back when we talked about the shape, right? Being a V shape. You had all those points down. Yes. Y'all got it? Y'all got it? Okay, now I'm going to take them and I'm going to do them in the right order. So first I'm looking inside here. I'm going to do this horizontal shift first. Or I'm going to add 2 to all my x values. I'm going to add 2 first. So let's add 2. You can put a little plus if you want, but it kind of negates it. So 2 plus a -2 gives me a 0. 2 plus a -1 gives me a 1. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. Ugh. So I've got that horizontal translation inside there first. Next, I'm going to do the dilations or reflections. So here we've got a dilation, and I am misspelling it every time. Somebody should fix it for me. I was I think it's misspelled every time on the whole video all the way through for the world to see forever and ever. Oh well. Dilation. It's because every time I say it, I'm sticking an A in there. Dilation. It's the text is draw. Dilation. There's an A in there. That's not there. Okay, so I'm going to do that dilation next, and I'm just going to take all I'm going to stretch it vertically. I'm just going to take all my y values and multiply them by 3. So I'm going to take all my y values and multiply them by 3. Yay, you got it. 6, 3, 0, 3, and 6. Genius. Great job. Now the last thing I have to do is my vertical shift or my vertical translations. So I'm just going to do this last vertical shift and move it up 1. So to all my y values now, I'm going to add 1. So I'm going to take and add 1 to all those y values. So now my new points are at 0, 7, 1, 4, 2, 1, 3, 4, and 4, 7. And those are going to be my new points. And it should take it and move it to the right 2, stretch it, and move it up 1. Let's see if it really does. 0, 7. 1, 2, 3, 4, 5, 6, 7. 1, 4. 2, 1. 3, 4. 4, 7. Sure enough, there's that V. It got shifted to the right 2. It moved it up 1, and it stretched it. Check that out. Now notice over here, it didn't really matter. We just did one operation to our x and one operation to our y. So it really didn't matter which one we did first when we did it algebraically. But here, on my x's, I just had one thing to do. So, that didn't really, which order we did it in. But over here, it was important which one we did first. We had to multiply here before we added. So with our y values, they totally make sense. With our order of operations, we always multiply before we add anyway. Or we divide before we subtract. So when we do our dilation and then our translation, it makes sense in our y's because we multiply and then we add or subtract. So that always makes sense with the order of operations over there with the y's. Not so much with our x's though, because our x's are big, fat liars. So let me give you an example. We'll do one last example, and then we'll call it a night. One last example where this time I got multiple things going on with my x values. So how about we do, we haven't done a square root, have we, tonight? Maybe we did, I don't remember. Let's do a square root, where inside I'm multiplying by some number, like 2. And then maybe I'm subtracting a number in there like 4. And then we're adding a plus 3 out there on the outside. So the first thing we're going to start with is that shape. It's our little teapot. Here's our spout. When we get all steamed up, here's a shout. Just tip me over and pour me out. So there's our spout there of our teapot. And you know the points are 0, 0, 1, 1, 4, 2, and 9, 3. Did I beat you? Barely. Okay, so now I've got my parent down. I'm going to look at each piece. So here, this 2, it's the multiplication, but it's inside with your x. So this is going to be a horizontal dilation. It's horizontal because it's affecting my x's, and since it's multiplying, it's dilating. We're going to have this dilation going on. So this is that horizontal dilation. And then I've got my -4. Again, it's inside with the x, so it's still a horizontal, but this is a shift. It's going to shift it one way or the other. Back to the dilation. It looks like we should multiply all our x values by 2. But we know our x's are liars. So instead of multiplying by 2, what are we going to do? Instead of multiplying by 2, we're going to take all our x values and divide them by 2. Every single one of our x values. Or you can think of that as multiplying by 1/2, whichever way you want to think of it. Mr. Jimson there would say there's no division, that you're just multiplying by a fraction. That's all we're doing. Good, that's exactly right, just divide. Now this one, instead of subtracting 4 from all our x values, we're going to add 4 to all our x values. And it's going to shift it to the right. This one's going to stretch or shrink it. It's going to have that. And then last but not least, this +3, it's out on the outside. So it's not affecting our x's, it's affecting our y's. And I think y's up and down, so it's a vertical shift. And the vertical shift affects my y values, and they're truth tellers. So we're just going to add 3. Let's add one more thing to this, just so I can show you I haven't shown you a reflection yet. So let me do the reflection too. Let's put this minus out front here. That reflection out front also. So stick a negative out front. And that's a reflection. Which direction is that going to reflect? That's a reflection. Which way are we going to reflect? Is that going to be a horizontal or a vertical reflection? Which way? And why? How do you know? What's happening to make it reflect? Which one is it affecting? Yeah, it's on the outside, so it's affecting my y values. I'm just going to take all my y values and multiply by 1. So y values are vertical, so this is going to be a vertical reflection. A vertical reflection. Oh man, there's a lot going on here. Good, it's because it's on the outside. You got it exactly. All right, so now there's a lot going on, so we really need to know our order of operations in order to do this. Notice there's 2 things happening with x and 2 things happening with y. And I'm going to move my little parent over here just to make it a little easier for me to work. So same points on my parent. Actually, better put it in the middle so I have room. 0, 0, 1, 1, 4, 2, and 9, 3. There are 2 things happening with x and 2 things happening with y. But which thing do I do first? I do my horizontal shift first. So you know, you would think with your x's that you would multiply or divide first before you add, but no, x's are liars. So just like with everything else, in here it doesn't make sense. Instead of multiplying or dividing first, we're going to add here first. We do this horizontal shift before we do the dilation. So anytime you're dealing with your x's, it really is backwards from what you think. Instead of, moving to the left, you move to the right. Instead of multiplying, you're dividing. It always ends up being the opposite of what you think. And even in the order of operations, you'd think you would divide and then add, but no, we're going to add and then we're going to divide. So I'm going to add these 4s to my x's first. So I've got 4, 5, 8, and 13. And then I'm going to multiply by that 1/2 or divide by 2, whichever way you want to think of it. Multiply by 1/2 or divide by 2. So 4 times 1/2 is 2. 5 times 1/2 is 5/2. 8 times 1/2 is 4. And 13 times 1/2 is 13/2. So my new x values are going to be 2, 5/2, 4, and 13/2. So I had to do 2 different operations to it. Horizontal shift first, and then the horizontal dilation. Over here, though, it totally makes sense. I'm going to have multiplication and addition. With my y's, it always makes sense. I'm going to do my multiplication first, and then my addition. My reflection comes before that vertical shift. And that makes sense. Multiply before you add. It's just the x's that are always backwards. I know. Stay away from those x's. They're awful. Just don't get in a relationship to begin with, and then you don't have to worry about x's. That's the real thing. Just stay away from them. So I'm going to multiply it by a -1 first. So 0, -1, -2, and -3. And then I'm going to add 3 to all of them. So multiplication and then addition. Totally makes sense on that end. 3, 2, 1, 0. So you just have to know when you're doing more than one thing with your x's, it's always backwards from what you think. So if you think you're supposed to multiply and then add, well, then it's the other way around. But if you just know your order of operations, that your horizontal shift comes first, that'll help you remember that also. All right, my new points. And let's see if it does everything we think it's supposed to do. So I should have a point at 2, 3. 1, 2, 1, 2, 3. I should have a point at 5/2. Well, 2 goes in there 2 times with 1 left over, so 2.5. So 2.5, 2. 2.5, 2. Then 4, 1. 2, 3, 4, 1. And this is 6.5, 0. Uh-oh. 5, 6.5, 0. I ran out of room. Now, I'm trying to figure out what's this shape. So let's think about it again. Here's the spout, and I'm taking and shifting it to the right 4. I'm taking it and stretching or shrinking it, actually shrinks it, and then I'm going to take horizontally, and then I'm going to take it and I'm going to reflect it vertically, and then I'm going to move it up 3. So this is the shape. It took my spout and it did all those things to it. So I'm going to take my spout And there's that spout. So you kind of have to think about what is that shape. Picture what's happening with your shape. And then this just gives you the points. And did that happen? Sure enough, it moved over, moved up, it shrunk it, and then it flipped it over. So it did all those things that we thought it was going to do to that square root function. So inside affects your x, and it does the opposite of what you think, because those x's are liars. Outside affects your y's, and does vertically, going to do something to it vertically, and y's are truth tellers. And then you're in, when you've got multiple operations going on, even there, your x's are liars, and your y's are truth tellers. So you do this in the opposite order that you would think, and this in the normal order you would think. Or just remember your horizontal shift is first, dilations and reflections, and then your vertical shift last. All right, your job is to get everything done now by Saturday at midnight. You got everything to turn in by Saturday at midnight. I'll be around some tomorrow to help out during the day. So y'all get it done, get it done, get it done. I'll be on Discord, so you can find me on Discord, or I'll be where you can text me. I'm going to really be available for y'all. My stats people should be done. It should just be all about college algebra tomorrow. So get it done. Get it turned in. Austin, I'm talking to you. So, all right. And I'll see you back on Tuesday night at 6 o'clock. Y'all rock. Stay safe. Math made simple at Simpson Math. Ah. Have a great evening. Great weekend. Good night, guys.